Good morning, students, we want to see today the simple queue versus circular queue. Now, simple queue, what is the difference between simple queue and the circular queue is in simple queue, even though the queue is empty, you cannot insert the element as you want because unless and until it reaches the end point, the front end points, it will keep first it has to be empty, then only you can enter the element. But in the circular queue, what is the differentials to overcome all this problem? The circular queue is made where the queue maybe the queue may have rear and the front end. Now you can set a initial location as wherever you want, and you can insert the element and if it is within the capacity of the queue. So this is the differentials between circular queue and the simple queue. It just go on inserting from the rear and then go till the front, and if you need to enter anything, you have to delete it from the front end. So that process goes on. There is a particular method that you have to follow. But in the circular queue, if you see this example, that when the front end is empty, you can also insert it, okay? And at the center, if you wanted to insert something within the space, if there is a space, you can insert it. So you can delete and insert it. So this is the differentials between circular queue and the simple queue. The algorithm is given here. You can see if you have to check the overflow of the queue, then what is the formula? That is if f equals to 0 and read equals to size, or f equals to r plus 1. It is like you have to have if you have to check it for the overflow, and you have to reset the pointer so that you can enter a new element. Then you have to have this formula. We give this formula so that the pointer can set it for the next element to be entered, and then it will go and check whether the rear is there is a space in the queue or not. To check this space in the queue, if r is equals to size, then it will see the r is 0, that's mean there is a space, and then it will enter the element as r plus 1 so that a new element can be entered, and then finally using this we can insert the element. Okay, so this is about the insertion, and this is how to delete it. This is the algorithm where we can delete it. So this is the formula that we use it to delete the element. First we will be specifying we have to go to the front end, because as the rule says, the element can be deleted from the front end. So where we have to delete, and then it will select the pointer exactly the place where you have to be deleted, and then f becomes 0. So here this is the till here there is an algorithm. Okay, if you wanted to delete the next element, then you have to use this f plus 1. So the pointer will keep moving like this. Okay, it will keep moving like this so that you can delete one by one. So this is a program that is given here. Okay, this particular thing is there for inserting a queue. Okay, insert the element in a queue. The similar if you see this algorithm, and if you see this program, if you see here, it is similar way. Okay, here we are writing it in the algorithm form, where we are writing in the alphabets or the sentences, using a sentences, okay, the main functions. And here we are using a coding, the program coding, that we have to do it. Like if you are writing it here, if r is equal to size minus 1. Now here how we indicate r is equals to size, but in computer we cannot write it as single equal to, because comparison is double equal to is used for comparison. So we are using it as r double equals to size minus 1, and then else r equals to r plus 1. So this is how we will be creating and forming a coding to insert the element in a queue. And next one is your deletion. If you see the similar way, if what it is telling, if f equals to null and r is equals to null, so how we can say here, if f is equals to minus 1, to indicate null we have to write here as minus 1, and r is equals to minus 1, then what it will show, it will show queue underflow. Else what it will have to show, you have to display this, that is val equals to qf. So here we are writing val equals to qf, then f, if f is equals to size 1, here if you see this line, okay, if f is equals to size, so here what it is telling, if f is equals to size minus 1, then what is the value of f equals to 0. So f equals to 0. Else what is the next coding here, if r is if f equals to r. So here what we are writing, if f equals to minus r. And then we have the similar coding how we write it according to the algorithm, and then just display it. Okay, display the element in the queue, what are the final element that we have to display it. So this is how we display. We use this for loop so that it is displayed in one space as we have it in the queue. Okay, so queue has to go one after the other, so we have to use this for loop here so that we can display whatever the element that is present in the queue. So this is about your uh, this is about your simple queue and the circular queue differentiation. Okay, so you can just go through the algorithm, go through the coding, then it will be clear like how the algorithms are written and how the coding has to be written. So please practice the algorithms also, because in your practical exams you have to learn the algorithms, how it has to be written.